Welcome to the Data Hall YouTube channel. In this video, we are going to work with the factor variables, or how do we define factor levels, recode the factor levels in R. So what we are going to discuss is how do we define factors, how do we drop unused factors, changing the order of the factors, or changing level of the factors. So let's get started. First, let's look at the package that we are going to use. We are going to use the forcats package that is part of the tidyverse package. Whether you use the load the forcats package or the tidyverse package, that's one and the same thing. But usually I do the practice of loading the tidyverse so that I can load all the packages that comes within tidyverse, like the ggplot, the readr, the stringr package, etc., etc. So you need to install these libraries. I have already installed them, so I'm not going to install it. I'm just going to load the tidyverse library. So once that is loaded, you can see that it loads the dplyr, the forcats, the ggplot to lubridate, etc. for working with different types of data. So let's move and let me first show you how the forcat package is, like, its functions are named. As with the stringr package that we discussed in our previous videos, it starts with fct. So the stringr package, all the functions in the stringr package starts with str, but in the forcats, all the functions starts with fct. That's way, if we know that this specific function is from the forcats package, we can simply, and we cannot remember it, we can simply write fct and search that function within the list, right? Okay, so let's move forward and let's define our data frame. Let's say we have this data that contains a name of different students, their level of education, different individuals, their level of education, and the marks that they have obtained, or the percentage of marks they have obtained in their last degree. So let me load this data and let me show you how this data looks like. We have names, education, the level of education, and their marks in last degree. So if I check the structure of this data, we can see that the marks is a numerical variable. It's structured as num. Its data type is num, numerical. Name is character, its data type is character. But this education is basically a categorical variable. It is by default categorized as a string or a character variable. And the issue with this is that if you are working with factors and there is some order in that factor, then it might not give us the meaning that we would want to derive from it. So let me arrange this data. Let's take this data and sort it based on education. And if I can show you this data again, it's sorted it on the basis of education. So shouldn't the primary be first, and then we should have the secondary level of education, and then the BS and MS. But what it did is it sorted it on the basis of alphabets, right? So B comes before M and so on and so forth. So it sorted it on the basis of on the basis of alphabets, as it would do with any character data. Now what we need to do is we need to define the factor variables. So first I'm going to discuss how do we define factor variable using base R, not in the forcats package, but in base R. What issue there is with the base R definition of factor variables, and then I'm going to look into the advantage of forcats and why defining categorical variables using forcats is more advantageous. So let's start with this. We know that there are 4 categories, but if we wanted to look into these unique values of those categories, we can use unique function and specify the specific column and the data frame, and we get these levels. Now let's first define the education level in a string variable. We're defining them in this order, and this would become the order of this categorical variable once we assign this education level to our categorical variable. So let's define this. Over here we have just defined the levels, right? Now what we are going to do is we are going to assign these levels to our education variable. So we take the data frame, and then we mutate a variable education, which is already there, but it would modify that variable. We want it to be a factor variable, that would take values from the education column by itself, and its levels would come from the education levels that we have just defined. And we want it to be saved into a new data frame, which is called students. If I execute this, show you the data, nothing happens, everything looks similar. But let's look at the structure of this data frame. You can now see that this education had been defined as a categorical or factor variable. And if you wanted to look at the levels of this education variable, we can see that these are the levels. Now, if you want to look at each category, each categorical, these are the labels, and they do have these numerical values. As you can see over here, these are different numerical values that have been assigned to these categories. If you want to look at these numerical values, we can have these numerical values because the first three are bachelor's, so these have a value of 3. Then we have MS, which is having a value of 4, and so on and so forth. So you can see that primary have a value of 1, then secondary would have a value of 2. So now there is an order. And if we arrange this data frame on the basis of education, we can see that now this student's data would be arranged based on the level of education and not based on the alphabetical order. So let's now this was when we had some order and we defined the order first, the levels first, and then we assigned it. We could have simply used the as.factor function. Let's take the student's data, mutate, make a new column, which we already have, but let's modify it, and using as.factors convert this variable into a factor variable, and let's save it into students factor. Now in this specific case, we didn't define any levels beforehand, and now this, although it had been converted into a factor variable, but the orders are not what we would have wanted. So let me arrange this factor variable, this new data frame based on education. Let me show it to you, and you can see that now in this case, although it had been, but usually it won't, because we took the data from the student's data frame. If we were to take it from the main data source and do it once again, you would see that the order is not according to the level of education, but it is according to the alphabetical order, right? So how do we define factors using forcats, and what is the advantage of using forcats? So let me change this factor. Let me change the, let's have a wrong spelling in the definition of these levels, factor levels, and let me execute this again and execute this part of the command once again. Now what would happen is, because we do not have secondary in our levels that we have defined, the labels that we have defined, what R would do is it would omit that, because now secondary, we had secondary in our data frame, but because that is not in the levels that we have defined, what R would do is replace it with the missing value. This NA stands for the missing value, and it didn't give us any warning. Now that is something that you wouldn't want to happen. If you have defined the key in a wrong way, then you would want R to give you some error. Now let's see what happens if we use the forcats package. So let's take this data and then mutate this education variable. Now using the FCT function, which comes from the forcats package, take the education, assign factors to it based on the levels coming from the education level that we have defined over here. They are still wrong, but let's save it into a new data frame, and let me show you this data frame. Now this data frame had not been defined, it had not been created. This is the old data frame that I created, and it gave me an error, and the error is saying that the missing level is secondary. Now if I corrected this, let me correct this and re-execute these commands, and now when I execute it, it would be executed, the new data frame had been created, and it looks perfectly fine. So this is the main advantage, that when you define some levels in a wrong manner, then this would throw an error. Now let's say, how do we drop an unused level? Let's say we take this student's data frame, and we just want to filter the individuals who have the MS level of education. So let's filter this, save it into this master's data frame. Now this master's data frame contains just two individuals. But if we look at the structure of this master data frame, we have 4 levels, right? All the primary, secondary, etc. levels are there. And if we look at the levels particularly from this master frame, we do still have these levels, because we had defined these levels in the student data frame, and although we have filtered it, but these levels just stick with this data frame, and that gets messy, because when we look at the levels using this levels function, we might get a wrong impression that there are 4 levels in this specific category, in this specific variable. So what we want to do is we want to drop all the unused. We don't know which one are unused, but we want to drop all the unused factors. So we take this master's data frame and then mutate this education variable, and we use the fact drop function to drop any unused factor levels from this data frame. And if I can show you the levels, now we just have MS. So let's move forward. We want to count the number of observations in each category. We use the count function, take the data frame. We want to count the education column, and then sort it on the basis of the frequency. So we have 3 individuals from BS level of education, 2 from master's level of education, and 1 from each primary and secondary. So let's move to another part of this video, which is how do we modify the order of this factor variable. So there are different ways of modifying the order. First, we can assign the order manually. We can change the order manually. I mean, we are not creating the order, but we want the order had been created in the student's data frame, and we want to change it. So we can change it manually, or we can change it based on the frequency of occurrence. So we want the highest frequency to occur first and the lowest frequency to occur so on and so forth. Or we can change it on the basis of the value of another variable. So let's start with the manual reordering. We take the student's data frame, mutate the education variable, and now we are going to use the factor relevel, which relevels the order on the basis of the order that we assign it. So we take the education column and assign this order. So what we want is we want the MS to appear first and then followed by BS degree. In this case, in the college level degrees, we want it to be in descending order, but in the non-college level degrees, we want it to be due to some reason, we want it to be in ascending order. And let's arrange it. So I can show you the data frame. You can see that now we have MS, BS, and then we have primary and secondary, the exact same order that we have assigned. Now this was reordering based on the manual reordering. Let's see if we want to reorder on the basis of the frequency of occurrence of those levels. So let's create a plot using ggplot. We take the student's data frame. On the x-axis, we want the education variable, and we want the bar chart. If I create the bar chart, now there is no order in it, although the number of individuals in our data sets are more from the BS level of education, but we would want it for it to give us more meaning. We want this visualization to be in some order. So one thing that we can do is before making this bar chart, we can use the fact in frequency that would order this education variable on the basis of the frequency of occurrence. And this is how it would look like. Now, if you wanted to reverse the order, we can use the fact reverse, and that would reverse the order. Now, in this case, we didn't change the order within the data frame. Rather, we change the order while we are plotting the data, but we can change it within the data frame. So let's take the student's data, mutate the education variable, that would change the order, use the fact in frequency, and change the levels on the basis of the frequency. If I store that and check the levels now we can see that the highest number of individuals are from BS, then MS, then the primary and secondary have one from each level of education. So that's how we order the frequency, we order the levels on the basis of the frequency of occurrence of those categories. If we want to order on the basis of values coming from some other variable, let's say we have this marks variable. Let's take this student's data, group it by education, and we want to summarize the marks. We want to calculate the mean marks for each level of education. So we want to take all the students, and let's say we have created this summarized. So we have this level of educations and we have their mean marks. Now we want to plot this. We want to create a scatter plot where we take the students' summarized data. On x-axis we want the marks, on y-axis we want the level of education. Let's create this one. We have this scatter plot, but we cannot make sense of it, right? But we would want to reorder these on the basis of the mean value. So let's use the same command, but now what I have done is I have used the fact reorder education variable on the basis of marks. So if I execute this, now you can see it is giving us a meaning. We can have a reverse order by just having this minus sign along with it. And obviously, as we did with the fact in frequency, we can build these orders, these levels within our data frame. Let's move forward. And now in this case, we are modifying the order. But what if we want to modify the factor levels? We want to recode them. Now there are two functions that we are going to look into. First one is the factor recode, and the second one is the factor collapse. So what factor recode does is it recodes the level of the categorical variable. So let's take the student's data frame, mutate, create this education variable, which is created already, but it would modify the levels. Fact recode, record the level of education, right, for the education variable for the education column. This is the new category, the new label that we want to assign it, and this is the old label. So what we want is we want to convert all the primary and secondary into non-college based education levels, and we want BS and MS to be college. So then we would have just two categories. And let's save this into this new data frame. So let me show you this data frame. We now have, instead of BS and MS, we now have college and non-college level of education. What if we wanted to collapse? Like in this case, we are actually collapsing, but this factor recode can be used for different categories. It doesn't mean that we just have to collapse them. It could have been like P, and then we could have given it like S, and this could have been B, and this could have been M. Now in that case, we wouldn't be collapsing them. So let me recode it. Let me show you the data frame. Now you can see that we have relabeled the values. But what if we wanted to collapse it? For that, the better function is factor collapse. What we do is we take the education variable. This would be the new category, and it would be assigned to multiple categories. This again would be the new category assigned to these old multiple categories. So in essence, what we are doing is we are collapsing the data based on create, and also creating new categories. So this is how it would look like. So I hope this video was useful. Do subscribe to this channel, do hit the bell icon, and thanks for watching this video.